वेलकम टू बिटूनेट कोड चैनल गाइस। आज के सेशन में CCNP में हम एक बार फिर राउटिंग देखेंगे। तो विल डिस्कस व्हाट इज़ राउटिंग एंड विल स्टडी इन डिटेल अबाउट स्टैटिक राउटिंग एंड डायनेमिक राउटिंग। हमने CCNA में ऑलरेडी स्टैटिक राउटिंग और डायनेमिक राउटिंग देखी है। तो चलिए अब CCNP में भी स्टैटिक राउटिंग और डायनेमिक राउटिंग के बारे में डिटेल से पढ़ लेते हैं। गाइस बिफोर वी गो अहेड लेट मी टेल यू कि हमने CCNA में क्या पढ़ा है और CCNP में हम क्या टॉपिक्स रिवाइज करने वाले हैं, राइट। ये मैं आपको ऑलरेडी बता चुका हूँ। राउटिंग कि कितने टाइप्स की होती है, स्टैटिक राउटिंग, डायनेमिक राउटिंग। Dynamic routing involves routing use of routing protocols like OSPF, EIGRP, BGP, redistribution, route filtering, etc. तो ये सारे टॉपिक्स हम CCNP में डिस्कस करेंगे। आई हैव ऑलरेडी मेंशन्ड इन माय प्रीवियस वीडियोस। तो आज के सेशन में हम डिटेल में देखेंगे राउटिंग बारे में। सो गाइज राउटिंग दो तरीके से होती है। इट्स ऑफ टू काइंड्स। One is static routing and other is dynamic routing. So in static routing we manually tell to router how to transfer the traffic, okay, how to transfer the data from which path to which path, okay. तो वो normally हम बताते हैं by mentioning the next stop where the router should send the traffic, or by mentioning the exit interface of the router, or we can also mention both. So this static routing is done by a network administrator, okay. And the other kind of routing that we have, that is called a dynamic routing. So that dynamic routing happens automatically, but we use dynamic routing protocols to do that routing, okay. So dynamic routing protocols are of two kinds. One is IGP, interior gateway protocol, and other is EGP, exterior gateway protocol. So our IGP protocols are of further three kinds. One kind of protocol is distance vector, that use distance or hop count as a parameter, and other is link state protocol, and third one is advanced distance vector, that is mix of distance vector and link state. So in distance vector we have two protocols, RIP, routing information protocol, and IGRP, okay. And in link state we have two protocols, OSPF and ISIS. OSPF stands for open shortest path first, it is a open source protocol, and ISIS is also a link state protocol. And then we have advanced distance vector, that is a mix of link state and distance vector. So EIGRP, that is a Cisco proprietary protocol, and it stands for enhanced interior gateway routing protocol. Then the other protocol that we have is exterior gateway protocol, that is a path vector protocol, and example is border gateway protocol. So internet mainly runs on border gateway protocol. guys चलिए अब आगे देख लेते हैं स्टैटिक राउटिंग। तो हम स्टैटिक राउटिंग कैसे कॉन्फ़िगर करते हैं। वी जस्ट हैव टू गिव कमांड IP route, network ID, subnet mask, and next hop of the ID where that should go. So to demonstrate this, let me take you to GNS. तो यहाँ पे guys मैंने IP addresses already configure करे हुए हैं, and this will be the network configuration. I have 3 loopbacks created on R1, 10.1, 1.1, 24 with the 24 subnet mask, 10.121 and 10.131. तीन नेटवर्क्स LAN नेटवर्क्स R1 पे हैं, 3 R2 पे हैं, and 3 are on R3, right? So let's go to R1. तो ये मैंने IP एड्रेसेस ऑलरेडी कॉन्फ़िगर करे हुए हैं। शो IP int brief exclude unassigned. तो as you can see here, R1 has fast Ethernet 0, 12.1.1 IP address, and this is up, status is up, and protocol layer 2 protocol is also up, and 3 LANs on we can say loopback IP addresses I have given on R1. Okay, similarly on R2 also show IP in brief exclude unassigned. तो R2 पे हमारे दो फास्ट इथरनेट कनेक्शन है 12.1.12 and 13.1.12. So IP address scheme that I use, if router 1 is connecting to router 2, I take that network ID as 12.1.1.0. Okay, and when R2 is connecting to R3, I take a network address as 23. I think I mentioned here 13. Let me check. I have taken 13. Okay, normally what I will do, let me change it to 23 for consistency. That is 0/1 23.1.1.2. Okay, so now it has 23.1.1.2. Similarly on R3 also, let me change it over here also. Similarly on R3 also, I use 13, so let me change it to 23. F0/1 IP address 23.1.1.2. Okay, so this is the network configuration that we'll be using, and on R2 F01, F01 is 23 and F0 is not there on R3, so let me remove the R3 F0 0/0. Okay, now it's fine. So we have 23.1.1.3 on R3 and 3 LANs 30.1.1.1, 121 and 131. Okay, and on R2 also we have IP addresses as 12.1.1.2 for F00 and 23.1.1.2 for F01. Okay, now this is fine. So now let's see, first of all, we have not done any kind of static IP routing or dynamic. So let's see what do we have in show IP route. Guys, by default a router will show only those networks that are directly connected to it. Okay, so we have 3 LANs created, and it says 10.1.2.1, 131 and 10.1.1.1. They are directly connected. Similarly, the other side of network 12.1.1.1 is also directly connected. Now this R1 does not know about 23 network and 30 network. So if we want to ping any IP address that is in 23 network or 30 network, R1 doesn't know how to reach there. So let's try to ping that 23.1.1.1. Okay, it will never be able to reach there. Similarly, R3 does not know any network of 12 and 10. So let's try to ping 12.1.1.1, and R3 will never be able to reach R1. Okay, or 12 network or 10 network. So in this kind of situation we have to tell routers how to reach those paths. So first of all we will do static routing. And how do we configure static routing? Let's see that. We use this command: IP route network ID, subnet mask and the next hop. Okay, so let's go back to R1. So R1 knows about these two networks, but R1 doesn't know about 23 network and 30 network. So these three networks, two networks, 23 network and 30 net, we have to inform manually. So let's do first static routing, and then we'll look into dynamic routing. IP route 23.1.1.0. Okay, and then it asks to give me the destination prefix mask also. So mask is 255.255.255.0. Okay, then it says tell the what you want to use, next hop ID or exit ID. Okay, we can also use here next hop ID or interface ID. So let's use here, we are on R1. R1 knows about 12.1.1.2. Okay, so we can give the exit interface as F00 or 12.1.1.1. Okay, so let's give the exit interface F0/0. Okay, whenever R1 goes to 23 network, it can send the traffic out of this interface. Okay, so let's inform same about 30 network also. 30 and make it 0. Now we have informed R1 how to reach these networks. Now let's see what is in the routing table. So here it says that I have static entry for a 23 network and 30 network, right? So now let's try to ping 23 network. 23.1.1.2. Okay, it is able to reach now. First packet is dropped because of ARP resolution, so that's why we always get 80% success, but subsequent pings give us 100% success. Now we should also inform R2 about the same. Let's see IP route. R2 knows about 20 networks, its own LAN networks to which it is directly connected, and 23 network and 12 network. But R2 doesn't know about 10 network and 30 network. So we will inform R2 about how to send the traffic to these networks. IP route 10.1.0.0 to 5.2.5.0.0, where it should send the traffic to fast ethernet 0/0. Okay, we can also give IP address, or we can also give a next hop ID. Okay, so I'm giving the exit interface address. So for 10 network, it should send the data towards left hand side. Okay, and for 30 network, it should send the data towards right hand side. Show IP route. Let's see if it has installed all the routes. Now R2 also knows about all the routes. It knows about 10 route also, 12 route to which it is directly connected, and 30 route also. So now let's try to ping 10.1.1.1. It is able to reach, and now let's try to reach 10.1.1. It is able to reach. Let's try to ping 3.1. It is able to reach. Okay. Similarly, let's try to ping 30. So we have a Okay, so we have 100% connectivity. Now let's see the routing table of R3. It only knows about 23 network and 30 network. So we will let R3 also how to route to 12 network, 12.1.1.0.2.5. Let's see how it gives us it. It says that enter mask also. So we will enter mask. Now it says give me the next hop IP or the exit interface. Right here it says you can enter IP address or you can give the exit hop. So what we will do, I will enter the next hop IP. So next hop IP is 23.1.1.2. Right. So for 12 networks send data to 23.1.1.2. Similarly for 10 network. Let's make it here 0 because 10 network is divided into 3 subnets. So send this also. Show IP route. Okay, now we can see that we have all the routes available in the routing table of R3. So let's try to ping 10.1.1.1. Okay, so it is able to reach. What about 10.2. And what about 300%? Now let's ping 12.1.1.1. Okay, so we have end-to-end connectivity now with the help of static routing. But guys, static routing is a cumbersome job if we have a very large network, right? We cannot depend upon administrator to configure static routing if we have large number of routers or very large network. So because there are chances of error. So in that condition we take help of routing protocols, dynamic routing protocols that are RIP or OSPF or EIGRP or BGP, right? So let's have a look about routing protocols. So we can see that in the routing protocol, routing table, okay, a router will always put the best path. So this is how dynamic routing protocols assist routers in calculating the best path to any network. So first of all, in routing table we will see directly connected the networks and static routes. So we just see here that now routing table router has installed connected routes and static routes in its routing table. Okay, so if we use a dynamic routing protocol like EIGRP, OSPF, RIP or BGP, then router will take help of these. And there are few parameters that are used to calculate best path. So first is called administrative distance. Now let's see what is administrative distance. AD is a 1 byte value. Its range is from 1 to 0 to 255. It is used to avoid conflict when a prefix has received from more than one source of information. Okay, it decides which source of routing information is best. Lower is the AD value, better is the trustworthiness of the routing protocol. So there are few predefined ADs. A connected route will have AD 0, static route will have AD 1, EIGRP has AD 90 and 70, OSPF AD value are 1110, RIP has 120, BGP has 20 and 200. So these AD values can be changed, but these are predefined, okay, and their value ranges from 1 to 255. So let's go back to our GNS. We can see here that Static routing is beneficial for small networks because it consumes less CPU and the configuration is simple, right? But if we have very large networks, then we take help of dynamic routing. So we will study in detail about dynamic routing now. Uh, Dynamic routing, we have further subtypes. They are distance vector and link state, and as well as advanced distance vector like EIGRP. Okay, and for exterior gateway protocols, we have a path vector, that is BGP. So guys, the distance vector protocols, they use distance as a metric to calculate the best path towards any network. Different routing protocols have different kinds of metrics. For example, RIP uses the hop count, that is the number of routers. Okay, and similarly EIGRP uses k values to calculate distance towards any network or any route, and OSPF uses cost to calculate the distance towards any route or any network, and BGP uses the path attributes. So here vector means the direction towards which the router has to go. So we will study all these things in detail. And guys, the distance vector routing is also called routing on rumors, because whatever information any router gets from its neighbor, it trusts that information and then calculates its own cost to reach to their destination. So that is why distance vector routing is also called routing on rumors. For example, let's have a look here. R1 router only know about near directly connected routers, right? It doesn't know about R3, R4, R5, R6, R7. So how it will come to know about other networks? It will trust R2 blindly about these networks. So whatever cost R2 will share with R1 about these networks, it will trust that and will add that cost to reach to those networks. Okay, so that is why this is called a routing on rumors. And now let's have a look at EIGRP, Enhanced Interior Gateway Routing Protocol. It is improved version of RIP because it has many additional features, like it's a distance vector. Its hop count limit is 255. RIP had hop count limit of 16, whereas EIGRP has a hop count limit of 255. It converges very rapidly and it does not send any periodic updates. Okay, it sends updates only when their change happens in the network, unless RIP used to send updates periodically, so that used to create additional traffic on the network. So that's why this has been addressed in EIGRP. It sends updates only when there is change in network, like any link is down or any router is down. Only then EIGRP protocol will share that information with other routers. It does not do any broadcast. RIP broadcasts all the updates with other routers. Okay, so those routers that are not even using RIP, they will also get those broadcast information, whereas EIGRP does not broadcast any kind of traffic. It sends at multicast, and multicast of EIGRP is 224.0.0.10. Okay, so link bandwidth is included in metric calculation. The protocol number of EIGRP is 88. Okay, and this is the multicast address, and the AD value used by assigned to EIGRP is 5, 90 and 170. We will study in this in detail. Hello timer that is used by EIGRP is 5 seconds. Hello timer is the keep alive message that is sent by one router to other routers to make sure that other router is up and working. Okay, and hold down timer is 15 seconds. That is normally 3 times of hello timer. So after a hold down timer expires and there is no hello from the neighboring router, then the router assumes that the neighbor router is not up, and then it removes that route from its routing table. EIGRP supports static and dynamic neighborship, and VLSM is also supported. By default it is disabled, right? But we have to enable VLSM on EIGRP, and EIGRP uses K values for metric calculation. So those K values are K1 is for bandwidth, K2 is for load, K3 is for delay, K for reliability, K5 is for MTU. MTU stands for maximum transmission unit, and there are no periodic updates. Updates are sent only when there is a change. Okay, here we can see that it sends unicast as well as multicast packets. When the IP address towards which it is sending the update, if it is a unicast, then it will send the data at the unicast MAC. If the IP address towards which it is sending the data is multicast, like this one, this is a multicast IP, right? Then the destination MAC that will be used, that will be the multicast MAC. Okay, so if it is a broadcast, then the broadcast MAC will be used, that is FFF. Here we can see that multicast IP will be this one. Excuse me. If the IP is a multicast like 224.0.0.10, then the multicast MAC that will be used, let me reduce thickness, then the multicast MAC that will be used will be 01005E 0000.0A. Okay, hexadecimal value for 10 is A, that's why MAC address will be this. Okay, and if the destination IP is a broadcast like 255.255.255.255, then the destination MAC will be FF. Okay, all F will be there. So this MAC will be used if it is doing a broadcast. Now we will just see how we can enable EIGRP on the routers, right? So this is the command that we use. We have to run command router EIGRP, then any AS number. Okay, and after that we use network and network ID, and after that subnet mask, invert mask, right? So AS number is a 16-bit value. It ranges from 1 to 65535. Okay, and this AS number is used to create multiple EIGRP domains. And domain is a group of routers under a single administrator. So this is used to ease out the burden on any network administrator. So we divide the network into different AS numbers. For example, in one domain we can keep 50 routers, okay, and in other domain we can keep other 25 routers. Now let's go back to our GNS and remove this static routing. So first of all, go to R1, to config terminal, IP route. We have static routing for 30 network and 20 network. Okay, control A, no. Control A, no. Right. To show IP route. Okay, now it has only connected network. Similarly, go to R2. Control A, no. Control A, no. Right. To show IP route. So now there is no static routing on R2 also. Similarly, let's go to R3. No IP route for 10. No IP route for 12. Do show IP route. Okay, now R3 also has information about directly connected networks. So now let's configure EIGRP router question mark. These are the routing protocols, dynamic routing protocols that we can configure on our network. One is BGP, Border Gateway Protocol, EIGRP, ISIS, IGRP for ISO IGRP, mobile, ODR, OSPF and RIP. Okay, so mostly we use EIGRP, BGP and OSPF, and in today's practical we will use EIGRP. Now let's give the EIGRP router AS1. Okay, now let's see what options we have, and there are a lot of options. So here now we have to tell about the network. Okay, what for which network, for which route we want to pass on the information to EIGRP. This R1 doesn't know about 23 network and 30 network, so we will give information about 23.1.1.0, then EIGRP wildcard mask. Okay, so this will be 0.0, this will be opposite of subnet mask, 0.255. okay, and then we have to inform about 30 network also, 255. Okay, so enter ELD show IP EIGRP neighbor. Okay, so show IP protocol. There is no neighborship created because EIGRP protocol is running only on one router. So let's verify the show IP protocol. If EIGRP is up, here we can see that EIGRP matrix that it is using, they are K1 and K3. So let me do one thing. Let me start capture and run Wireshark on this network. Okay, right now this is CDP information that is traveling on the wire. So okay, and let me tell you details about this also. So these are the metrics that will be used. We just saw that K1 is used for, let's go back to our nodes. Here we read about parameters used by, okay, we can also check it from here. Here we will, guys, I recommend that you follow the CCNP routing 300101 book also for detailed information. We will just check about distance vector and what is the definition of distance vector protocol. before that, let's do the demo. So hop count of EIGRP is 100, variance is 1. All these things we will discuss in the coming session. Right now we don't have any neighborship, so once we start EIGRP on router 2, okay, I think I did some mistake. This network command, unlike static routing, we run EIGRP only on networks the router is directly connected to. So let me make that change. I'm sorry for that. ERP and do it no. We will only inform about directly connected network on this EIGRP protocol should run 10.1.0.0 0.255.255. Okay, similarly the other network that is directly connected to R1 is 12 network. EIGRP protocols. IP protocols. Okay, now we can see that. Okay, one more thing that is recommended in EIGRP does network summarization, automatic network summarization. Okay. So we should know auto summary. We should always run this command also. Okay, now automatic network summarization is not happening, and this is routing for these two networks, this network and this network. Now let's go to R2. Okay, to R2 also we will inform that on which networks EIGRP should run. So EIGRP should run on 12 network and 23 network. So let's inform on 12.1.1.0 0.0.0.255. Okay, similarly about 23 we can see that we got the message about the new adjacency happening. Protocol. Okay, and EIGRP neighbors. Okay, it has created neighborship with 12.1.1. Now let's see, here also we got the message new adjacency created. Show IP neighbors 12.1.1.2, right? And let's go back to Wireshark EIGRP, and here we can see that hello messages have started coming, right? Let's study first message. Okay, this packet is going from 12.1.1, that is R1 to destination multicast IP 224.0.0.10, and let's study this EIGRP packet. So EIGRP version 2 is running, and opcode for hello message is 5, right? And these are the parameters that will be used in EIGRP. So it uses K1 and K3 only K3, K1 and K3 are on. Okay, K1 is for bandwidth and K3 is for delay. The rest are not used for calculation of matrix, but they can be configured. Okay, software version is 12.4. let's check the next message. These are same messages because till that time neighborship was not created. So let's read this one, update message. Okay, here it got the hello from other packet, so it was able to get the ID of the next router. So that's why this packet hello is sent from 12.1.1.1 to 12.1.1.2 instead of multicast type. Okay, so reply is coming from 10.12.1.1.2 to 12.1.1.1. Okay, so here we can see that ACK is coming. So after this ACK is received from the other router, then the neighborship is established. Okay, now let's enable EIGRP on R3 also. Router EIGRP1 network. EIGRP has two network, 23 and 30. 23.1.1.0, 0.0.0.255 and network 30.1.0.0, 0.0.255.255. So IP EIGRP. First let's see address, neighborship is up, new adjacency created, right? Show IP EIGRP topology. Here we can see that in topology table is created before calculating the best path, right? So here we can see that it has one successor and feasible distance to that successor is 435,200. And this is the reported distance, RD value 409600, that is reported by this router, and this is the value calculated by R3 to reach 10 routers, right? So EIGRP makes use of feasible distance and reported distance. This is the feasible distance, okay, and this is the reported distance. This is the RD value, reported distance. So based on the reported distance value received from the other router, okay, it calculates its own cost with the help of K parameters, that is bandwidth and delay, and then it calculates its own cost to reach any route. So here we can see that 435,200, 409600. Okay, let's go to R2. Let me show you this over here also. We can see that here it says D. Okay, all these D are path, show IP route EIGRP. Okay, these are the path that are calculated by EIGRP. D stands for dual. Here we can see that D is for dual diffusing update algorithm. This algorithm is used by EIGRP for calculating the cost of reaching the other network. So all the paths that have D in front of them, they are calculated by EIGRP. So EIGRP is showing summary path also, because we have not enabled auto summary. We have not disabled auto summary on R2 and R3. So we will do that. Here we should not see summary path because we had a disabled auto summary. So here we have a summary. So let's EIGRP no auto summary, and Okay, so it will negotiate the neighborship once again and will do the calculation once again. Router EIGRP now it should not show us the summary part. Show IP route. Now we will shortly discuss how to calculate these FD values and RD values. Before that, let's go to our routing book and discuss the theory. What is the distance vector protocol? A distance vector routing protocol sends a full copy of its routing table to its directly attached neighbor. This is periodic advertisement, meaning that even if there have been no topological changes, distance vector routing protocol will at regular intervals re-advertise its full routing table. So this is the what is a distance vector protocol, right? A link state we will discuss when we will do OSPF, right? And this is the algorithm that is used by EIGRP. EIGRP uses for its route selection shortest path algorithm. I'm sorry, not a shortest path, but it uses a diffusing update algorithm, DUAL. That's why in its routing table it shows a path as calculated by D, right? Guys, as we can see in our Wireshark that EIGRP is sending all the hello packets at its multicast, right? IP that is 224.0.0.10. Okay, we can see that all the hellos are sent by all the routers at 224.0.0.10 from 12.1.1.2 and 12.1.1.1. Okay, we are capturing this network. If we want, we can stop this multicast and can also configure static neighbors of the router, right? So let me show you how we can do that. For that, what we will do, we'll go to R1 router EIGRP1. Here we can use neighbor command. Okay, we can manually inform EIGRP that its neighbor is 12.1.1.2. Then it will send hello packets at 12.1.1.2 IP address, not at multicast, right? So let's do that. Neighbor 12.1.1.2. Okay, where is 12.1.1.2? It is at F0/0, 0/0. Okay, now the neighborship will break, right? We can see that fast Ethernet is down, static peer configured. Okay, let's go to this also. Now packets are coming only from packets should be coming only from 12.1.1. Let's see what do we have in this. Okay, now we can see that packets are going statically. If we try to do show okay, neighborship is down. It does not know about its neighbors. Okay, because EIGRP neighborship has broken. So for that, this network command should be run on other side also. Only then the neighborship will come up. Now neighborship has broken. So look at this message. What we will do? Router EIGRP can see that adjacency has come up. Okay, now we can see that routers have come back to show IP route EIGRP. Okay, earlier routes were not coming, now routes are coming, right? So if we configure the network as static, then the neighborship will come down, and static command should be configured on both the neighbors, only then neighborship will happen. So now we can see that when we have configured the neighbors as static, it is not sending hello packets at multicast IP, it is sending at unicast IP to its neighbor, static neighbor only, right? So this is the difference between using dynamic neighbor with the help of EIGRP or configuring static neighbor. Let's check a little bit more about this static neighbor, EIGRP neighbor. Okay, do detail. Now it mentions here this is a static neighbor, I'm sorry, right? And the whole time is 11, and since the router is neighborship is up is 1 minute 34 seconds, smooth round trip timer is 1310 milliseconds. Okay, so this timer is the time it takes to go from this router and traffic to come back to R1. Okay, let me draw it over here. So smooth round trip timer is SRTT. So this timer will be time it takes to the time it will take the traffic to go from here to here. This is called smooth round trip timer, right? And then we have RTO. RTO is a retransmission timeout. Okay, this is considered when there is a timeout, no response come from for the hello packets, and then not hello packet, sorry, for update packet, right? We'll discuss that shortly. Now let's see how we can change the hold time and hello timers of in EIGR. So for that we have to go configure hello timers for networks. We'll have to go to interface mode. So let's go to F0/0. Here we can give command as, here we can see it has hello interval, right? Configures IP EIGRP hello interval. IP hello interval. Okay, EIGRP. We can, okay, autonomous number is 1, and this is the number of seconds we can configure when the hellos should be sent. Okay, depending upon the traffic or our production requirement, we can make it 1 second, 2 second, or 3 second, or longer than that, right? If we configure it, we saw that our hello timer was here we saw a whole timer. Okay, let's go to R2. So from here we can change the hello timer, and we can also change the whole timer. Okay, if we go to wireless, can see here that it says hold time 15 seconds, okay, in every packet that it is sending. So hello timer is 5 seconds and hold timer is 15, 3 times of hello, okay, that is 15. So we can also configure hold time. So for that we will go to interface, and we are already in interface mode, okay, EIGRP 1. Okay, this is the seconds before a neighbor is considered down. So I can change the hello timer and both hold timer, okay, from this command by going into interface mode for R1 from here, okay. So let's try that also. Let's try to make it let's try to make hello timer as 5. From 5 to let's make it 3. Okay, now let's see, let's go to EIGRP Wireshark. Now it is sending hello packets more frequently. Here we can see that earlier it used to send after 5 seconds, 1974 plus 5 1976, okay, and now it is sending after every 3 seconds, okay, 9 plus 3 12 plus 3 30, okay, 13 point some microseconds. So now it is sending hellos more frequently, okay, and we can see that in here the hold time is still 15, okay. Normally it should be 3 times of hello, so we should change the hold timer also, and hold timer we will be able to see on the next router. This means that when the other router should consider me dead, right? So let's configure here hold time EIGRP 1. Okay, let's make it we made it 3 for hello and 3 9. Okay, now go to Wireshark. What is the hold timer it is showing? We can see that here hold timer changed to 9. Here it was 15, and when we configure the command, now it is showing hold time as 9. Okay, whereas the hold time that is coming from other router, that is still 15. So we will check that also. Okay, show EIGRP neighbors. Here the hold time for F00 is 6. Okay, it will start reducing from 9. Let's give it again. Okay, whereas for other end it is it will start reducing from 15. Now it is 13 seconds, but toward this end, toward 12.1.1, it starts reducing from 9, then 8, then 7, then 6, then 5. Okay, and after every 3 seconds hello comes, and then it resets back to 9. So it should reset at 9 minus 3 6. Whenever, as soon as it reaches 6, okay, then hello comes and it goes back to 9, and then it again starts the countdown and reaches 6, and by the time it reaches 6, again hello comes and it resets to 9. Okay, so this is the hold timer that will be visible on the other router, on this router. If we configured a hold timer on this R1, it will be visible on R2. This hold timer is to inform the other router that consider me down only after hold time of 9 seconds. Okay, whereas hello timer is for its own, how frequently it should send the hello messages, right? So this is the difference between hello and hold, and how we can check them. So guys, this was the video about EIGRP till now, and in the coming videos we will discuss more about EIGRP, like topology table, how EIGRP calculates the cost, and how EIGRP does the load balancing. Okay, in case you have any doubts or questions about what we discussed, please let me know in comment section, and don't forget to subscribe to the channel. Thank you and have a great day ahead. Bye bye.